So in this question, a Ferrari passes a point at 22.1 meters per second and then takes 1.4 seconds to accelerate to a speed of 46.3 meters per second. Calculate the magnitude of the Ferrari's acceleration. So this question is a little bit trickier, but still works the same way as other problems. So the first number I've been given is 22.1 meters per second, and that's the initial speed of my Ferrari. It then says it takes 1.4 seconds, which is a time, to accelerate to a speed of 46.3 meters per second. Notice that none of these values have the vector symbol over them because we're talking about speed. We're not talking about vectors, so we're not including any vector arrows. And the question's asking me to solve for the Ferrari's acceleration. Again, it's only the magnitude, so there's no vector sign above the acceleration. So when I look at my formula sheet, the formula that we need to use is A equals VF minus VI over T. In this case, that variable that I want to solve for is already isolated, so I don't need to manipulate the formula. I simply need to plug in my numbers. A equals my final velocity, 46.3 meters per second, minus my initial velocity, 22.1 meters per second, divided by my time of 1.4 seconds. This is a little bit more complicated to type into the calculator because your calculator doesn't understand the order of operations without brackets. So in this case, I need to do my subtraction before I do my division. Therefore, I'm going to type in an open bracket, 46.3 minus 22.1, close the bracket, and then divide by 1.4. The answer I get is 17.2857, so we'll say 17.29. Because it's acceleration, my units are meters per second squared. Now I need to look back at my question, and I notice that one of my values has 3 significant digits, one has 2, another one has 3. Because there's multiplication and division in my question, I'm using the rules for multiplication and division, which means using the least number of significant digits. In this case, 2 is my least number of significant digits. Therefore, I'm going to round my answer to 17 meters per second squared.